microservices in Go. Two topics, I guess, that I'm pretty interested in and passionate about, and I think also two things that kind of go hand in hand and work really well together. So, a bit about me. My name is Ian, as Ryan said. I started using Go maybe a little over 3 years ago. I was at a conference, OzCon, and I saw Brad Fitzpatrick give a talk on how he rewrote the download server using Go. And at that point I was mainly a Java developer and kind of getting sick of the Java world and looking for something else, and this looked really cool. And it looked interesting. So I started playing around with it, probably like a lot of you guys here, kind of build this simple web servers that you can do quickly, started building some tools, some little demos, tried to sneak it into work where I could, some testing, some stubs. And at this point, I guess I would call myself kind of a Go cowboy, just kind of hacking code together and building stuff that was cool and interesting, but nothing that was really production ready. Weren't really using it where I was working, so I wasn't building, web scale applications. This, I guess, is a good time to see kind of the obligatory Go Amsterdam Meetup questions. So, who here is writing Go code? Pretty awesome. How many people kind of doing it on the side projects, tooling? Cool. People doing it professionally, working somewhere with writing Go? Awesome. And actually running it in production? That's pretty cool. Yeah, I've been coming to these meetups since I moved to Amsterdam 2 years ago, and I think the first one, there was very few hands that went up for those questions, so it's cool to see that it's growing. And so that's kind of one of the themes of what I want to talk about, is moving from this language where you can just quickly build something, tooling, some quick demos, some POC, to something that's really ready to run in production. Because I think also this is one of the images and one of the problems that Go has at a wider scale is there's a lot of larger organizations. I don't want to say enterprise, but some of the big companies, they're a little bit more wary to adopt Go in their company because it's kind of missing something or doesn't give off the right appeal, so that maybe they'll go for something like Scala instead. But I think this is not accurate. It is ready for these kind of things, and I think we're all Go fans here, so we can all kind of agree on that. But this is about microservices in Go, so let me just kind of switch themes for a second and talk about microservices. So, everybody here familiar with the term microservices and microservices architecture? Thanks. Cool. Similarly, anybody working somewhere where you are writing microservices, developing them in Go? Bonus points for that. Cool. Also better than I expected. So I want to give a bit of a background, I guess, on what I think of microservices is and how we should be building them. Apparently, we have a lot of people doing it already, so I'll go through that a bit quicker. And I apologize for this terrible Venn diagram. That's not really a Venn diagram, but it kind of served the purposes I wanted, so I used it. So microservices is kind of a bit of a buzzword, right? There's a lot of interest and a lot of talk around it. It's been getting really popular lately, but a microservice is just a small application, right? So why is it suddenly really interesting? And I think there's three kind of influences or three areas that have made this time right for microservices, I guess you could say. So if we look architecturally, we've had things like SOA, which people don't want to raise their hands to say they're familiar with SOA, I understand. It had some really good ideas and kind of some similar ideas to microservices that we would kind of break out our applications to have expose specific pieces. It kind of got sidetracked and I think and taken over by some vendors, so it lost its way, but I feel like we've taken the best pieces of SOA and it's still going on in microservices. Organizationally, so stuff like Agile and more recently DevOps has become really popular in a lot of places, and these are things that coincide really well with microservice architecture. something where we have kind of these rapid iterations, these small teams and ownership. This fit really well. And then finally, technology. So look at stuff like container technology, specifically Docker, which is made really popular recently, and programmable infra. This is also something that aligns really well with microservices, and I think the combination of these three things has made it gotten really popular recently. So a bit more on if you look at, this is actually from the Linux philosophy, where you say write programs that do one thing and do it well. And Linux has been around for a long time. This is again the same kind of idea in microservices, right? We want to write something that's small and performs one kind of concrete function. So when we're actually building and developing microservices, there's certain things we need to keep in mind and certain characteristics, I'd say, that we want our services to have. So we want our services to be elastic. And that means that we can scale them easily and independently. So if I have one service or one part of my application that's getting really hard with a lot of traffic, I just want to be able to spin up 10 more instances, whether manually or automatically, and that kind of solves the problem for me. But there's certain things we need to have in order for this to work, right? We need to kind of minimize state within our services. We need stuff like load balancers to sit in front of these guys. Otherwise, how is the traffic going to get split out across things? We want our services to be resilient. So this is, I think, one of the big shifts that happens as we move to microservices, is that previously we were very focused on avoiding failure and avoiding errors and making sure that none of this bad stuff happens. But we need to kind of understand that there's stuff's going to break, right? Servers are going to go down, there's going to be networking issues. This is stuff that's going to happen in production in the wild. And we've kind of shifted to this mindset where we should have services that handle failures and accept them and don't crash and just do gentle degradation, that kind of things. So again, when we're building services, we need to take this into consideration. So we need things like circuit breakers in place so that if the database that we connect to or the other service we need to get information from goes down, we're not just going to fail. Maybe we'll have some fallback data, but we're not just going to crash. We need our services to be composable. So a microservice in itself is not an application. It should be able to stand on its own, but it's not going to offer any significant service. We take a bunch of our microservices and we put them together to build our actual application. So what does this mean? What do we need to take into consideration? So if our services need to talk to each other, and maybe they're running on different hosts, we need some networking involved. We need service discovery so that they're able to find the pieces they need to talk to. Minimal. That's kind of the core concept of microservices, right? They're small. It's difficult to say, what really is. You can't put a line of code or a number of lines of code to say how small a service should be. But we want to focus on our services not being bloated, and we're not just developing monoliths all over again. So that we need proper patterns and good idioms in place for when we build these. And finally, complete. So complete, kind of within the domain, a service should have proper bounded context, but also it needs to have kind of all of these standard features that we come to expect in an application. We need logging put in place. We need monitoring. These pieces need to be built into all of our services. So kind of the microservice promise is that we can kind of choose any technology. And all of our teams are free to pick whatever language they want to program in and whichever database they want to use. And this is true to some sense, right? There's a lot more freedom. But all these pieces that I talked about, the service discovery and load balancing and all of these things, we need to put these in every service. And we don't want to be building this stuff 30 times over. So I just wanted to switch threads for a second. It was a multifaceted time. Threads, programming, socks. Sorry, I was really proud of myself when I came up with that joke. So this was a project that I was involved in a couple months ago. There was a partner company of ours who were preparing for DrCon in Seattle, and builds services that focus on containers and focus on kind of microservices for their products. And the problem was that they built their services and they were really cool, but they didn't have anything to demo it on. And so we kind of looked around, and there wasn't really, a microservices application that you could pull off the shelf and just run. It was either something that was just, much too simple, or it was just, a real application. So we decided to build one, which was pretty cool. It was in about 2 weeks, and we were just, I would say it was aggressively microserviced. So I think there was 12 pieces involved. We tried to use a bunch of different technologies just to show off the stuff again. So there was some stuff built in Java, in Node, obviously in Go, different databases, all that kind of stuff. But again, this was a demo, right? This was something we threw together in 2 weeks. So when I talk about 12 services, this was our payment service. It's almost embarrassed to put this up there. But this is, again, kind of one of the, I would say, benefits that you have of Go is you can put something up really quickly in, 10 lines. So that was cool. But then after the conference, we kind of realized that this thing had potential and it was interesting and it was something we needed or we wanted. So probably other people were looking for it too. So we decided to kind of keep the project going and shift it from just like a demo application to an actual reference application for microservices. So this was kind of our plan. So obviously, if we're going to put something forward to the community and say this is what a microservice application should be, we can't have this, right? This is just not, we're going to get laughed at. So there was a lot of kind of decisions and talking that we had to go through into how do we build this into a proper application. So again, there was a lot of pieces, but we did have, I think, four services written in Go. And actually a colleague who was working at this company, at Weaveworks, his name is Peter Burgon, and he used to work at SoundCloud. And they were kind of one of, if not the first guys to really use Go publicly in production. And they were running it for a long time. And out of that, they had built, specifically he had built this framework, or sorry, this toolkit called GoKit. And GoKit is branded itself as a toolkit for microservices. So they say it's a collection of Go packages to help you build robust, reliable, maintainable microservices. And actually I was looking through the documentation in the website, and I think purposely avoids the word framework anywhere. That's kind of a loaded word, and I think rightfully so. Myself specifically coming from kind of traditionally a Java background, anything with the word framework kind of scares me. I didn't want frameworks to sneak into Go. But this isn't really a framework, so it kind of does a few things for us. It defines this layered structure of how our services should look to kind of provide us with the right patterns and provide a good level of abstraction. And it also offers a lot of packages that we can use as tooling for building or plugging in all of these services that I mentioned earlier that we need when it comes to building a microservice. So if we look at how a service is modeled in kind of the GoKit land, we've got this kind of onion layer. And we have this kind of separation of concerns where the inner layer is what we care about, right? This is our business logic, this is our application logic. Ideally, this is the stuff that, the only stuff that we should be writing and we should be caring about. But then, we always have stuff on top, so we've got service metrics, we have logins, the stuff we need to take care of. And as you move higher here, when you get into kind of these external services, this is something that's going to be kind of consistent throughout your services. And this is something that you don't really want to be writing every time. This is not something I should care about when I'm trying to develop a service. So the idea is that this is stuff that should be taken care of by this toolkit. And at the outermost layer, we have our transport layer. So the idea of abstracting this is that really you get that this is, so for example, if we choose HTTP and REST or JSON, we can extract this and kind of have this abstracted in a certain layer. So if later we want to swap that out for, say, gRPC, what I'm talking about next, we can do that pretty easily. So let's jump into some code. and take a look. I've kind of taken a simplified view of one of our services that's part of this reference application. So if we start at kind of the inner layer, we start at this idea of a service. So what are really offering? And kind of the easiest way to line this up is a service is essentially an interface in Go. So at the innermost layer, we define that. So here, for example, we have service. This is for a catalog service. So this is how our front end or anyone else gets what kind of stuff we have in our catalog to offer to sell. So here we've got two functions, to list and to get, and that's our interface. And then on top of that, we're going to create, so kind of like a constructor to instantiate that, and in this case we're depending on a database. So then, and again, the service, as this is our inner layer, this is really where our business logic is, our kind of domain application logic. So this is what our service is really doing. So in this case, if we look at how the list is implemented, essentially we have a layer on top of our database. We get some query parameters, just some parameters, and we translate that into a query into our database, retrieve our data, parse it, handle it however we want, and we expose it. So that's kind of the innermost layer. And then on top of that, the next layer is what's called our endpoint layer. This is essentially an RPC abstraction on top of our methods, so that we have for each of our functions that we have inside of our service, we're then going to wrap those into this endpoint. So you see, we have the corresponding two endpoints from our service, or from our function, sorry. And then we wrap them here. So we pass in a context, which we're going to pass down through, and then basically the request. And then we just return a response and an error. And this error here is not like, this is kind of your outward facing error. So you can think of it in HTTP terminology as maybe, as like a 404 or something. It's not like kind of like a null pointer or something. So we just wrap our methods inside of this function, and then we get these endpoint objects. And so again, we have kind of our requests and our responses defined for each of our methods. In this case, because we are using JSON and HTTP, we have those tags. And then as we move to kind of the third layer, this is the transport. So again, this is everything that's specific to the protocol that we've chosen. In this case, as I mentioned, it's HTTP in JSON, but this could easily be, this could be Thrift, this could be gRPC, and you can swap this out pretty easily. So the Go kit kind of provides some helper functions for each of these kind of protocols. So in this case, we're building actual HTTP handlers. We're passing in our context, our endpoint which we created, and then these would be our functions for decoding and encoding our request and our response. So since these are specific to the protocol, these will exist in this transport layer. And again, we do this for each of our methods that we've implemented in our service. So, and just a quick look at what those encoders and decoders look like. Basically, we're taking, in this case, kind of the HTTP objects and just wrapping those into our local model. So pretty straightforward. So that's it. We've kind of got our three layers, and then really all we're left with is our main. And this is basically where we just kind of wire all these pieces together. So we create our background context, which gets passed through. In this case, we've got a database, which will set up our connection. We instantiate our service, create our endpoints, and then just kick off our handler. And that's pretty much it. So this is kind of a bare bones, minimal service in GoKit. But one of the kind of major advantages or the strong points is the idea of middleware. So a middleware is something that we're going to kind of inject or have sitting in between for all of our requests or all of our methods. So one common example is logging. Obviously, if an application is not logging, then it's not really doing much, and there's no point of, it's not something we're going to put into production. So if we want to create a logging middleware, in this case, so we just define this, we create our logger, and you can see here it's actually got a reference to our actual service. So it's kind of like you can think of in the Node.js kind of express model where you kind of pass along the requests. And since we have defined our service as an interface, we're going to take this middleware and it's going to implement that same interface. So we can see here the same list method that we had defined. It implements that, and that allows us to kind of get inside and have access to all of the application level details. So we're not just logging kind of request and response time and standard metrics, but we actually have access to, in this case, the requests and the responses to actually log specific or interesting details. And so we would do this optionally for each of our methods. So again, that's kind of a pretty bare bones look at a GoKit service. There's a lot of other features and kind of the pieces that I mentioned that we really need when we're building a microservice. So stuff like circuit breakers, rate limiting, load balancing, service discovery, monitoring. These are all packages that are available that you can just kind of optionally pull in. So for in our case, the application we're developing is deployed on Kubernetes. So we already had certain things like load balancing and service discovery taken care of. But something like circuit breakers is something we're trying to implement now. And these are just packages that you can kind of pull in, and essentially the work's already done for you. So kind of a look at what our experience was in using GoKit to kind of build these proper services. We found there was a bit of a learning curve, and there's a strict kind of model that it wants you to adhere to. But I think the benefits of the payoff is worth it, because it really provides these strong patterns that give you this abstraction by default. There is, as you could see in some of the, for example, in the endpoints, there's a lot of boilerplate code, which is just kind of needs to be there. Which is a little wary of, but apparently he's actually working on code generation in Go to actually just generate this stuff for us in the future. Again, maybe this was just me, but I was very worried that it kind of felt like a framework initially, but I think after working with it, there's enough of it that's optional, so it's not really that heavy. It's not heavy enough that I would call it a framework. And again, it encourages this kind of low coupling and high cohesion among your services, which is a nice benefit. And all of these different features, this circuit breaking and this load balancing that you can just kind of pull in if needed, I think is very valuable. And then the pluggable middlewares. So the example we looked at was logging. You can do this kind of with anything, with monitoring, or you can write your own custom middlewares. Anything you want to sit in or plug into all of your requests coming in. We found this was good for newcomers to Go. So for example, on this project, we had some new people come in who were not Go programmers, and to kind of give them this to start off with, it was nice in that you kind of instill in them already some good patterns, where there is not trying to, for example, write Java in Go, which is something you can kind of see a lot. And finally, I think, to come back to my point earlier, this is one of the things that makes Go as a language more attractive to kind of bigger organizations. I feel like this is kind of the structure that a lot of them are looking for when choosing a language. And that's it. So I would encourage, there's a lot of people here who are writing microservices and writing Go. I'd encourage you to take a look at the project. It's got some pretty good documentation in there. The code's all open source. There's a Slack channel. They're all pretty active in the community. And additionally, the SOC application that I've kind of shown off, this is something we're trying to make still a reference application. So this is where it lives in GitHub. So feel free to take a look. Pull requests, anything is welcome. And that's it. Thanks. Any questions?
Yeah, so you mentioned that it's really, so it wants you to follow the patterns that it tells you to.
Yes.
But how much did you feel that you were able to also sidestep them when necessary? So is it flexible?
Yeah, so so for example, we did, and there are certain places where we did kind of sidestep around this. For testability, for example, there were some pieces where the way it was set up, we felt that we couldn't properly test them, so we extracted some things to a different level. But the kind of three main layers is more or less strict. But then again, I mean, in the end, it's just packages, right? So if you don't want to use them and you just want to use, for example, the circuit breaker piece, you can just pull that in. So I think in that sense, that's where it's not a framework, and it's more just really a toolkit that says you can pick and choose the pieces you want and leave the rest. Okay.
What does the circuit breaker precisely do on yours?
In this case?
Yeah.
So it's essentially you kind of define some parameters. So if you're trying to reach some other service, some other party, and you're not getting a response within a certain amount of time, or you get a certain error, basically you define kind of what the fallback behavior is. But looking to play with that soon. So.
What about the performance when you insert a lot of these middlewares and stuff? Because it drops a lot of because last days I read about the Iris sort of framework. They actually say that it's the fastest for today as HTTP framework for Golang or so.
So really look at how the maintainer of Iris is treating open source, how he's treating pull requests. The guy is in love on that.
Well, I just read the article.
Yeah, no, the guy is not open for reasoning. He's closing issue reports. He's hostile towards other people.
Who's that? Sounds good.
Iris.
At least I can say Peter's a nice guy. So. But that's a good question. So we actually didn't look at measuring performance yet, but it's something worth looking into for sure. When choosing something like this, obviously you want to see how it impacts.
Right. Okay.
Yes.
Does the framework help with the documentation, generating documentation for the service?
No, not at all. Yeah, there's nothing for documentation generation built in. Yeah, I'm not sure if it's something they're looking at or not.
So your code is the best documentation.
Right? If you write proper code,
Of course.
you don't need documentation. And you don't need tests.
Well,
just wanted to add that he asked about the performance with the middlewares and all that. When you're using middlewares in Go, you're just passing a function as a parameter, and those are pointers usually. So there's nothing really special that will degrade performance. You're just passing a function.
so technically it's just a few ticks. Yeah,
And if you want performance, you probably shouldn't be using HTTP anyway. Which is a nice segue to the
The
next one.
difference between gRPC and HTTP in GoKit is incredible. So if you can go gRPC, do it.
Yeah. I 100% agree.
I'm a little bit caught up there. I wrote the binding.
Unbiased opinion, I agree.